Hello everyone. Welcome to the session on the state of public transit routing on OpenStreetMap. So if you're wrong, if you're in the wrong room, you can still change. Yes, everyone is here? Yeah. Okay, first I have a question for you. You don't have to answer it right away, but how far do you live from work? Keep the answer in your head. Right? And now I want to ask you a question on the units that you used. Raise your hand if it was in kilometers? Okay. And raise your hand if it was in time, like minutes. And this is really interesting. Because if you know, because about 50% said, hey, yeah, it was in minutes. If you now want to create a program, a computer program that does this calculation for you, for instance, if you want to check out where you want to live next, or if you want to check out your next job, then you want this kind of calculations. And just imagine the amount of data that you would need in order to get to an answer to that. And it's not only OSM data. That's the interesting part. It's also data about public transit schedules, but also data about criminality rates, for instance, because I don't want my itinerary to always go through places that have a high criminality rate, and so on. So for this session, we will have three interventions first. The first one will be by Tristan Grabner. The second one will be by Tuka Hastrup. And the next one will be by Emily Eros. I would say, without further ado, Tristan. Yeah, and afterwards we will have a panel, so you can also prepare questions for this panel. We will keep all the questions for after the three talks. Yeah.
Thank you, Pieter. Thank you, Pieter. So I will talk about just a plain old CSV file. And the context is I used to, on which screen does it, which computer is linked? This one?
This one, and you have to go.
Oh, yeah. Okay. Yeah, thank you. I used to work for a company that changed a bit of the name, Captain Train, which wasn't international enough, so it became Captain Train. And it was bought recently by Trainline, so it's Trainline Europe. And what they do is they're connected to different booking systems. So the four biggest are Deutsche Bahn, SNCF, Trenitalia, and Renfe, but also for smaller train operators, like the private Italo or HKX, or the subsidies like Ouigo and IDTGV, which are having different booking systems. So the idea is to distribute any train ticket through just one web page or one application, and especially have worldwide by far the best customer service. And I'm saying that even if I don't work there anymore. So we needed a station database. There are multiple reasons. So OpenStreetMap, you always think of a map, so we need coordinates. Use that for geofencing. So if you get at the station, you get a notification, okay, your booking is car number 4, seat number 26. So when you get in on the station, you know your platform, everything you need to travel. Well, of course, maps. And to find for booking from the nearest station to save some time. But also, every booking system, I showed they have like 7 or 8 different booking systems and a few other in progress. They all have different identifiers for every station. So if you want to book a train ticket from Paris to Köln over Brussels, you have 2 different companies, and Brussels doesn't have the same identifier. So the database stores also this information. And we have also some very specific metadata to know if you can get your ticket at a station or you need an office or send it by mail and things like that. So we use different data sources. Well, first carriers have some open data databases. We used OpenStreetMap. The partners gave us different files. And we made a lot of internal crowdsourcing because we didn't have any coordinates for every regional bus. we sell, and we wanted to have the coordinates, so we made some application to map that. So obviously the database is an ODBL because the SNCF database is ODBL, OpenStreetMap is ODBL, and the other ones agreed to republish it in ODBL. So basically it's just a CSV file on GitHub, and it's quite active. So there are about 600 commits, and every commit is activating, deactivating a station, changing the name, fixing translations, activating, deactivating, adding new identifiers. And one interesting thing is, as we put it on GitHub, we have quite extensive unit testing with tons of different rules to see if it's coherent, if the coordinates are not somewhere near Null Island, or if the name already exists, or if the identifiers match. And we always work by pull requests, because it's not always clear if this station belongs to Brussels. Let's say the nearest station, I don't know how you pronounce it, Etterberg or something like that. If you type Brussels, should you also try to book a ticket from that station or not? And this kind of things, we make pull requests and we comment this openly. So, and at last we made some tool. I will show a screenshot right now. So I think the very interesting part of this project is really, the data is very minimalistic. Could be, initially it was a SQL database, but they didn't allow to make pull requests, which were quite important. To know the history, who made this change, and we can ask why he made it. And unit testing saved our asses many times because we went too fast, or somebody changed something without knowing the consequences with other carriers. So yeah, this is quite interesting approach, I think, for having this data and using developer tools to manipulate it. So, because everybody is not a developer, we made an user interface like this, which is like a huge form with, well, I think 20 possible values. And you can see, for example, the identifier for the Deutsche Bahn, for Renfe, or the UAC, International Railway Organization. It's almost the same, but not completely. So this is kind of things we have to manage on a daily basis. And the map allows to correct the position of the stations, because nearly all stations were wrong. On small city, because it was made on the town hall and not on the station. On bigger station, it was off by, was in the centroid of the station and not on the passenger building, what we're interested in, and so on. And to go back to the original theme, so we used OpenStreetMap coordinates, and it would be great to push it back, but it's not that easy. One reason is, what is a station? We made very strong assumptions that it's really the passenger building, and OpenStreetMap sometimes maps just stop points. I'm thinking of a bus stop, which is run by, which has national-wide transportation. Sometimes the bus stop is mapped on both sides of the street, which, when we sell a train ticket, is not interesting. We just want to give one name for the station and not the pole where you get off, on and off. So the mapping between those is difficult, so it's a work that should be done almost line by hand. And, well, you know, you get carried away by other priorities, and we didn't do it. So one answer is to say, hey, it's open data, do it yourself. Of course, not an acceptable reason, but must be done. And then there's a question, how do we extend it to all the public transit and not railway station? Because there are extremely few stations in Europe, like 30,000 or something like that. And it's not even the number of stations that is in the Paris area, if you take all the buses and so on. And making the decision of the station, the stop point, is very important if you want to go from subway to the bus. So it's a lot of work too. So I have no clear answer how that could be done. And it's always a recurring theme of making a station database. There are projects in every country, sometimes state-backed, sometimes not, but nothing really emerges here. So I don't know if other people interested in public transit and OpenStreetMap have an idea how this could be done and how we could have this databases of all the stop points, stop areas, and stations. So just some things to think about it.
Thank you very much, Tristram. So the next speaker will be Tuukka Hastrup from Finland, who claim to be very advanced in public transport route planning and mobility as a service. Let's see whether that's true. There you go.
Yeah, I think some of that is like what our government wants the reality to be, and then we are working towards that. Maybe not quite there yet, but thanks, Pieter. So yeah, I'm from Helsinki Region, HSL, the public authority there, and yeah, so we don't operate the public transport. Companies do that, and we don't hire bus drivers and so on, but we organize the lines, the IT systems needed for ticketing and passenger information. And this covers all the regional traffic, so buses, trams, metros, so on. And just to give you an idea of what kind of a region is this, so around 1.3 million inhabitants, and quite a lot of public transport use in that. There's 1 million boardings per day. And to give you some kind of idea of, most of the lines are bus lines, and more than 300 of them to take care of. And a new addition is these city bikes, which is still a small system, but similar to what you can see here, and it's proven very popular and increasing the use of bikes in general. So our current journey planner, to give you an idea, people love it. We've had it for a long time already. And so to give you an objective measurement of how much they love it is that we do these questionnaires where they are asked whether they would suggest their friends to use our web application, and the recommendation score is more than 50%, where anything that would be positive is seen as a good result. So really, people have not much to complain about it. And part of it is because we provide open data and open APIs. So if someone is not happy with our one user interface, then there's tens of mobile applications that people can choose from. If you're an Apple user, you can find a nice Apple application. If you're an Android user, there's a nice Android application. Pebble watch interfaces and so on. Here's an example of, wanted to show you a map. So from a fan, he designed a better schematic map than the official one. Gives you an idea of the, we have only one subway line, but then the commuter rail and some of the trunk bus lines form something of a subway network of this small city of only around or a bit over 1 million people. And what problems we had with the old system, which had closed data. So there's a long list, and I don't think it lists everything, but just starting from thinking of when we pay for the data, we're trying to be as efficient as possible. So we try to use as little data as possible, whereas the best service would be the one that took advantage of as much data as is available. And it's fragmented, it's a crazy amount of work to... yeah. So it's this fragmented data sets, combining them, And when the datasets are updated, you have to do the manual combining again. So our region covers 6 different municipalities, so they have different datasets, and they are not even comparable in formats, and so on. And still, it's incomplete, so we need to add walking paths, which are important for public transport users, but are not included in these databases that we have used this far. And it's slow to update, so these sources typically they update once or twice a year, and then we do the manual processing and so on. So when new housing is built, for instance, it takes a long while before we can route there, unless we do the manual work of adding temporary approximate geometries for these paths and so on. Yeah, and still there's some things that we haven't managed to do manually that we should have. So for instance, the mapping of exact walking paths to all the 8,000 stops, that's not something that we could really do. So then there's these inaccuracies of how long is the walk really between 2 bus stops, for instance. And yeah, the base map is again another data source, so actually it doesn't necessarily match what we show as the route for the user to take. And in the end, with all these open data and APIs from ourselves, we can't share along the data that we use to calculate the route. So all these other applications, then they typically display on top of, for instance, Google Maps, and it doesn't exactly match our geometry, so it creates confusion. So the result answer that we're now working on is called DigiTransit. It's now in beta. Integrating all your travel information is the idea for the customer, and in the back end, it's supposed to be all 100% open, so open data, open source, open APIs. Yeah, so the schedules are in what we provide as open data in this standard GTFS format, which is simple and nice. And then vehicle positions, estimates of the arrivals to the stops, and alerts regarding disruptions we provide in various real-time formats. So there's a couple of big standards, Siri and GTFS real-time, and we try to support both of them. Then addresses we take from OpenStreetMap. Unfortunately, in Finland, the situation isn't so good that it would be enough to use addresses from OpenStreetMap. So then in addition, we use the government published dataset that covers all of Finland, which is integrated into openaddresses.io database. And yeah, in addition, we use who's on first for the municipality and locality and so on. Lots of place names that are not yet in OpenStreetMap. So these are then combined for the geocoding functionalities. And new APIs that we provide now, we can provide the raster tiles for the base map, but then also vector tiles. So if someone wants to style them separately in their app, then they can still use our API. There's also some other data. So for instance, the stops are provided as vector tiles. So it's more efficient, better caching and so on compared to querying by bounding box from a REST API. Then we use this quite new API technology called GraphQL, which makes it possible to make all kinds of queries from, for instance, mobile applications. A REST API can mean that you have to do lots of queries to display one page. Or, on the other hand, it may be very fixed to only show a predetermined set of information. Instead, here you describe a query. It's kind of limited. It's not SQL, so it doesn't open up us to all kinds of denial of service type of use. There's some limits, but still it's very useful in practice. And then for real-time data push, we use this new standard called MQTT, where a mobile device the application can subscribe to a specific set of information. For instance, whenever a vehicle on line number 550 moves, send me an information right away. So the mobile applications don't have to keep pulling for movements. Instead, they can wait for movement information to come to them. And all these combined mean that there's now this buzzword of being serverless. So it's possible already to create these public transport applications without having your own server. So then it's popular with students and hobbyists to also create these applications without having to have their own server, taking advantage of our GraphQL and MQTT platform. Then for open source, we use various components and try to contribute upstream. So our own user interface, that's what we did from scratch, but based on HTML5, React user interface library, Leaflet for maps, of course, Pivik for analytics, and Sentry for error situations. So these are all open source components and services. Then OpenStreetPlanner is what we actually use for calculating these public transport routes. Also, this GraphQL API, we contributed there, and it's now included in the 1.0 release that happened recently. I'll talk a bit more about what all OpenStreetPlanner provides later, but it's been I would say this project wouldn't have been possible if OpenStreetPlanner didn't exist already. It provided us a great foundation. Then, geocoding using Pelias. We're trying to contribute to make it the best geocoder for Finland. I'm optimistic that we will get there. It's been a bit difficult with some remaining internationalization and localization work needed there. Base maps then using OSM to vector tiles and our own style based on OSM Bright. And we also publish in GitHub the Docker deployment scripts, so it's actually quite easy to spin it up, for instance, on your own laptop to have a test on all of the system. Then there's this bit that is still not open, so the font we use is not openly licensed, and likewise for our logo, but everything else you can make a almost 100% copy of our service then and tailor your own version of it. So here's an example of what it looks like when you open it. So obviously we try to geolocate where you are so we can give you the context. And often this works, and this may be all that you need. So journey planning traditionally has meant typing in where you want to start and where you want to go, but actually the information you might need might be here already. Okay, the pink circle shows me where I am, and I can see the train station nearby, and I can find my way there and find my train if I already knew that I wanted to take the train, for instance. If the geolocation fails, for instance, that's why we show the pop-up in the center, so you can tap there and do a geocoding for starting from another origin point. So here's, for instance, I change it to Hakaniemi to show another area. And this is a better image in that here you can see all the different, the color circles are the stops, and you can tap any stop to see the next departures from this stop. If you already know which stop you wanted to use, you still don't have to type in anything, which is very practical for mobile users. Then from the bottom, you can open these tabs. So if you're not interested in viewing the information on a map, instead you want textual information. So this is like your private departure board. concentrated on the origin, showing closest lines and their next departures. This is often what you want to see from a real-time system. You might have these on bus stops, but for instance, we can't have a display for all the 8,000 stops, so then this works as a kind of virtual version of that. Also works for people with vision impairments or so on. Then the other tab is your favorites. So if the list of lines was too long there, then if you have marked your favorite routes and destinations and so on, you can probably already see the information you wanted to see. What's the closest stop for the line that I always take home from center, for instance. Then we can show real-time information. So when you click on one of the departures, we can show where it's arriving, so you know if it already went past your stop or where is, when you're waiting, you can see it approaching slowly. Or you can view the whole, not just one vehicle, but all the vehicles on the same route to see whether you could catch the previous one, or maybe you want to spend more time and catch the next one. Then when you have given the destination, then we can calculate these routes using OpenStreetMap and display the results. So at the bottom you see 3 different suggestions regarding what might be your favorite option of these, and then showing also on the map whether, when you go around, whether you go from north or south, for instance, here, just to give you some idea where you're suggested to go, which way. And then we can show the itinerary as these instructions. This is still something to work on. Would be really nice to show nice walking directions where you have to turn and so on, but we've had some issues with this. So for instance, the sidewalks often don't include the name of the street, so it would need some kind of pre or post processing to add the names of the streets to the instructions. So currently you only see the geometry of the walking path visually. Regarding current coverage, so we do Helsinki Region, and then it's a 50-50 collaboration with the Finnish Transport Agency, which covers all of Finland, so also including the long-distance buses and trains and so on. And then there's this new consortium of all the other Finnish cities. They have a travel card called Valtti together, and then they are working on bringing localized versions of this to each city. Then we collaborate with Norway. They wanted to do a national journey planner as well, and they found our work to be a good starting point for their work as well. And then there's some more informal work. So for instance, this one operator in South Tyrol in Italy already started to deploy this as a test for their new information system. And there's, hopefully there's one EU project now ongoing, and maybe more in the future to bring this now first to Tallinn in Estonia. Yeah, so some more details about OpenStreetMap if you're not familiar with it already. I think it's less known compared to OSRM because currently no one provides lots of public instances of it, so you would need to install your own for your region. And of course, it's not enough to have only OpenStreetMap data if you want to do public transport routing as well. But the nice things are that it can do these multimodal combinations. So first you walk to the bus stop, and then you take a train, and then maybe in the center you use a city bike for the last kilometer or so. And yeah, it takes care of elevators, escalators, so on, including car for first driving to the station using your own car. And it's very flexible. There's lots of configuration you can do when you do the routing request. For instance, for bicycles, you can say whether you want a short route or one that has not many hills, or one that is safe in that you don't have to bike among cars and so on. And interestingly, we're following this work on a project called R5, which is by the original developers of OpenTripPlanner, creating a next generation which is faster and lighter, so it should be more viable to run this, for instance, on a mobile phone for completely offline usage. And I'm thinking what this kind of use case brings to OpenStreetMap. I think I'm very optimistic that it will provide new users for OpenStreetMap and more exposure. Because people want to go places, so they need some way, and currently OpenStreetMap.org front page doesn't give you the option of public transport, so people are forced to use something else. Maybe someday we will have a solution that we can deploy globally for all of OpenStreetMap. And I already noticed that we are raising awareness. We are one government project, then we talk to other departments. For instance, they ask us why we don't use their map data, and then we explain how OpenStreetMap is better for some use cases and so on. And yeah, we can already see that, of course, where more people use OpenStreetMap, the maps are of better quality, so we hope to bring a lot of more users, especially in the national version. The Helsinki coverage in OpenStreetMap is already so good, but more use in the countryside hopefully leads to more contributors from the countryside. And we are planning to do some mapping work of our own as well, so some things that are missing and that are important for us, then the work that we did earlier to keep kind of a private amendments to the available data sets. In the future, we can contribute them directly to OpenStreetMap. Just to give a wish list of what kind of problems we've seen so far. It feels, at least in Helsinki, that the community isn't so wide and inclusive. So the HOT project has already, with their mapathons, I think, given a nice boost in multiplying the amount of active mappers and people who know about OpenStreetMap and who are participating in the events. Then it's a good question whether we should have something like our own namespace when we disagree with the OpenStreetMap consensus on something, for instance, whether you're allowed or whether it's wise to walk somewhere. We think that you shouldn't walk at someone's backyard, but if the community thinks otherwise, we cannot change that, but still maybe our official journey planner suggestions shouldn't tell you to walk in someone's backyard. So one idea that we have come across is this: maybe we can add this kind of our point of view. I know it's not objective and it's not maybe grounded on the objective reality, but this might be a kind of compromise we could make. Then there's some of these questions about our data sets which are not copyleft, and then ODBL, how to make the separation clear. So currently we first produce the GTFS data, and then afterwards we match it with OpenStreetMap data. So this way we have both one set which is not copyleft, and then after matching we have the version where the geometry is matched nicely to OpenStreetMap, and then that is ODBL licensed and not appropriate for all kinds of uses or all kinds of licensing scenarios anymore. So it would be nice if it was all clear to everyone what is copyleft and what is not, and what is allowed and what is not. Yeah, there is an ongoing import of government open data Finland-wide from the National Land Survey of Finland, but it's been progressing quite slowly. It's been ongoing for several years already, and I'm not sure how to speed it up. Maybe with all the new OpenStreetMap contributors from Finland, we can set up some kind of countrywide hackathons or mapathons to improve the import work. And finally, there's been some interesting discussions here now and talks about how the indoor work is progressing, and we're very excited about that in the public transport side with the stations, for instance. I think one part of why they are not mapped as good as they could be is just because it's so difficult trying to view all the different levels of the station as a flat visualization in ID editor, for instance. So yeah, thanks, and there's some links for the resources, also a demo of what this looks like in Belgium if you want to test it. Yeah.
Thank you very much, Tuka. Yeah, I think what you've shown here is like really what we can do with open data today, with open source software today, and yeah, we're quite there, right? Like everything is almost fixed. Everyone with a budget, at least a certain budget, like from the government of Finland. If you have your own government, and if you can actually also secure a budget, you can set this up and you can have a decent public transit route planning. So that's why I'm also really happy to have the next speaker, who's going to give the other side of the medal.
Great. I'm less tall. We're good? So my name's Emily Aros. I'm the GIS team lead at the American Red Cross, but in my past life, I'm actually trained as an urban planner and specifically worked on open data for informal transit in developing countries. I'm going slide free today because when Pieter said panel, I didn't think presentation, and I happen to be laptop free. So you guys are going to have to give me your rapt attention and also imaginations. One thing that I found really interesting being here at State of the Map is that in my work context, I work with collecting data for settlements in rural West Africa or Rwanda or countries all around the world where we have to send somebody to walk 10 kilometers just to get the name of a village and put that into OpenStreetMap for the first time. At the same time, I'm hearing from SNCF in France, who is collecting the location of every single clock in every train station in their whole country. And you know, OSM has so many use cases, and it's amazing to me that we have a platform that can meet all of those needs at the same time. And it's exciting to see how passionate everyone is about their particular use case because they're equally important. So my background is informal transit, which works a little bit differently. And Pieter asked me to be on this panel just so that as we're thinking about, you know, areas where we can have real-time transit information, we're also keeping in mind places where there is no transit information or not publicly available or held by the government. So in the past, I worked on data collection projects both for MIT and the World Bank, where we collected route information for Dhaka, Bangladesh, Nairobi, and Mexico City. And we're able to send out students using different apps. There's Transit One, there's Flock Tracker, there's a bunch of different apps out there that you can use to collect your GPS traces as volunteers go out, turn those into shapefiles, compare those to OSM, and then create paper-based transit maps for the first time. If you've seen the Mapanica project from Managua, those guys were doing a very similar thing, but what's really exciting about their project is it's the first example I've seen of one that's crowdsourced and locally led. The others have usually been outside institutions coming in. So those guys are fantastic. But what informal transit tends to look like is a much more decentralized version of what we have. So rather than a centralized transit agency operating different routes, This is multiple private companies, sometimes hundreds of private companies who have a franchise or the permit to operate a particular route. And in that context, data is power. What I found from working with these agencies is they tend to have very, very good information about exactly where their buses run, but it's not available. So in Mexico City, if you go to ask the government where all of the colectivos run, they'll say, yes, yes, we have it. But if you keep asking, you find that there's a binder, stacks of paper that hasn't been updated in 10 years, and all it says is roughly a destination and roughly the origin, and that's all you get. And these are systems that in Mexico City, informal transit is 60% of the ride share. This is 14 million person trips per day, and really very little information about where does this actually operate. So as soon as you start thinking about how do we introduce, like in Bangladesh, they're thinking about how do we introduce mass transit for the first time? How do we introduce a BRT system? It's very difficult to do that when you don't know how millions of citizens are already getting around and where the demand is. So there's been a number of projects that have sprung up in the past few years to get a sense of, well, how does this operate? Where do these trips run? So collecting apps, using apps, collecting traces, making paper-based maps, and then a lot of these projects have gone towards making GTFS data feeds. And that's been a little bit of a challenge because a standard that was created for Portland, Oregon doesn't necessarily work in a place like Paraguay or in a place like Bangladesh. The key issues that we run into are frequency of trips, or schedules. It may take you 4 hours to get across the city. It may take you 1 hour. The route might look like one thing on a Monday. It looks differently on a Tuesday based on local conditions. And so we're working with GTFS, but we're also having to make a lot of kind of fake fields. And there's a group of professionals that are in a working group kind of trying to deal with this and come up with a GTFS flexible standard, so that at least even if we're all kind of faking it a little bit, we have an understanding of the areas that might not be 100% perfect. And so this is something that's still being worked out. The World Bank is kind of taking the lead on that at the moment. OpenStreetMap plays in because as soon as you're collecting traces of where the routes go, you need something that you can overlay that onto. And OpenStreetMap is generally the best available map for these areas. So we're pulling data from that, but we're also pushing it back in there. Especially at the Red Cross, we don't really work with transit data, but when we send people out all over West Africa, we collect the traces in the background, and then we're able to collect that amongst hundreds of volunteers, put that into OSM, because as far as we're concerned, like, that is the road network. So we're creating this in real time. Another thing with OSM is that similar to how GTFS doesn't necessarily fit perfectly to a developing country context, the way OSM does things is a little bit different as well. So for example, if we're thinking about how do we put in a station, how do we put in a stop, that looks differently because a stop is not necessarily a point-based feature. A stop might be anywhere on this road or anywhere in this square. So we have to think about, well, how do we work with this? I think mapping transport has also been really good for creating interest in OSM. Lots of people may not be aware of OpenStreetMap, but as soon as you have a use case that depends on having OSM, as soon as you have an app that uses OSM in the background, there's an added incentive to keep that map up to date. And it's also been really good for working with local governments and kind of advocating for ownership of your own data. Typically, governments will get a road network file by hiring a consultant. They go out there, collect the data, but they maintain ownership, and they maintain that in a shapefile, or even sometimes all the government has is a PDF. And then every new administration has to go through that process again because the data will get lost in transition. So OSM is kind of introducing a new awareness where people see that it's actually easy to create this on their own or easy to access it from an open source place, and that it's kind of democratizing data in new environments. So that's my background. So I'm kind of adding the informal context to this panel, and that's all I have.
Thank you very much. You should really learn to manage my expectations better, because this was a very great presentation. Thank you. Now I would like to invite all speakers to the panel, and I would like to add one more, like someone who doesn't really have a lot to say about public transit, but he has a lot to say about route planning. That's true, right, Johan? Yeah? Yeah, okay, yes. So I didn't insult you. That's already good. That already went better than my previous talks. I'm looking for the microphone. Technical people, do you have well, there it is. Okay, can we give it to Johan for a start? Yeah. So Johan, can you introduce yourself, please?
I'm Johan. I work at Mapbox in Berlin, and I work on OSRM, the routing engine that we built. It's open source, but you can also use our API, which is Mapbox Directions. OSRM is a routing engine that does shortest path routing on road networks. It works with car, bike, and walk routing on OSM all over the world, and it does not work with public transit. The reason why it doesn't work with public transit is because actually, as we also a bit saw in Tuka's talk before, it's kind of a different problem of routing shortest path on a road network and doing public transport routing. The biggest difference is that with public transport, you have a schedule. So just because there is a train line doesn't mean it makes sense to take that train line if the train only comes every 30 minutes. Whereas with a road network, if you start now, you will be able to make progress the whole time, and you don't have to wait, except if there's traffic jams, but then you basically model these by just saying you can go slower on the street. Ironically, there's like some overlap between the transit routing and the routing with public transport, and that is bridge closings, tunnels, and ferries, which are all things that OSRM cannot handle well at the moment. It's basically a different style of routing class where you have to say, it makes sense to wait here. Like routing algorithms have trouble dealing with wait times. I think we will never really implement public transport routing in OSRM because, thank you very much, Pieter. Because it's just different algorithms. What we would do if we would implement it, and we actually started working on prototypes, but then realized, oh, this is bigger than we thought, of course, is we would probably use the connection scan algorithm that KIT has some papers on. So the Karlsruhe Institute of Technology has worked on this and published some papers that had new algorithms that are like fairly fast and that seem well. Still, to deal with the multimodal approach. So multimodal routing means you use different kinds of transport for coming from your start to your destination. So, for example, the case that we've seen in public, or that is typical in public transport, is you walk to the station, you take public transport, and then you walk to your destination. But this, in the cities of the future, I think always imagine that there would be way more modes of transport. So I would hop on my hoverboard that I rent, and then like go through the park to the bus, and then I go with the bus somewhere, and then I go in my Hyperloop tube, and then I go into a car sharing, and this would be like the fastest route I could take. This means crossing a lot of different services that have different capacities, availabilities, schedules, prices, all of these things that I have trouble imagining all would work in one routing engine. Like, there's definitely other people who think differently, and I hope they are right. How I see these systems would be built, the multimodal cases, is you have several routing engines for each of these cases and have kind of a gathering approach where you query them with an algorithm that sits on top. And you ask, so what's all the public transport stations around me? How could I walk there? And then what is the public transport stations that are near the destination I want to go? And then try all the connections between these. OSRM can play a role in this because we have algorithms that help you with that. So driving to the station is something that OSRM can help with. We also provide distance tables. So distance tables are basically routing between many different points. So going from finding, for example, the nearest public transport station, you could put in all the public transport stations within like a 10 kilometer radius, for example, and then ask how long does it take to get to each of them, for example, by foot. And then select the best one of that for your routing path.
All right, very interesting. And OSRM, that's something that the people in the audience, they can install right away from osrm.org, I guess?
Project-osrm.org.
Right, yeah.
We also run a demo server. It was funny when you said that one of the reasons why OpenTripPlanner is not used much is because there's no demo server. Yes, OpenTripPlanner should have a demo server. Mapbox is running the demo server for Project OSRM. Costs us a couple of $100 per month to just in running cost, which is expensive. The thing we get out of it as a company is that we basically run master on it. So every night we install the latest version of OSRM on it and see if it still works. So it's also our like integration test platform, which is definitely great for us in seeing that the changes we do don't break anything.
That's really interesting. I have a lot of questions for you, but because of time constraints, I'll quickly shift to Tuka, for which actually Tristram introduced a really nice question. How would you deal with stations lists just like Tristram dealt with? How are you doing it right now for Finland, and how would you do it worldwide? Will that be one GitHub repository with all stations worldwide, or how will you scale that up?
Maybe I missed why not have it all in OpenStreetMap. Maybe we have to work on the actual model for what kind of tagging schemes we use and so on, but I think we can improve them for different use cases. At least, yeah, of course, working only in one Western country is easy in that we haven't so far seen any issues in using the current tagging schemes in Helsinki and in Finland.
Okay.
Maybe you want to expand on.
Yeah, I think OpenStreetMap would be a great place to do it. The thing is, I think struggling with having a national database which is normalized. Maybe Finland has this kind of database. United Kingdom has it. France doesn't. And I think there will be a lot of tears and crying mailing list about how you should represent it, because one need is to have the identifier to query your API, OpenTripPlanner, which ID should I use? And people locally would think otherwise because they want to represent how it looks like and not how some random server somewhere thinks it is. So having this distinction between how one information system sees a thing, which is maybe different from the theoretical data to the real-time data, which might have different IDs and different vision of what is a station. With informal transit is another huge thing. Some countries use blocks, like intersection of streets. Somebody use just different streets. Some have areas, and all these things is quite difficult to make a worldwide database difficult. I think at one country level, the culture is quite the same of what is a station. I think this cultural thing would be difficult. And the idea behind this is not mapping the world as we see it, which is kind of the OpenStreetMap goal, but how to interact with computer tools that need some information. And the boundary is difficult.
Now that you mentioned these different ID schemes, it reminds me of one problem we have is that we do matching based on stop code. So there's these 4-number codes for every stop. And these can then be also, they're included in our data and APIs, and they can be included in OpenStreetMap because it's visible at the stop. But then actually we have these special cases where the stop doesn't have a stop code, so then the matching doesn't work here. So it's been for reasons like the stop is only for not getting on the bus, but only leaving passengers there, so no one actually needs to find their way to the stop. so it didn't have a code. But now we have a reason to have a code so that we have these IDs that work to match different data sets. So in the government, we are then working to add the necessary codes. And yeah, so this works in Helsinki level. Then nationally, I think at least European Union regulations say that each country is responsible for assigning these consistent IDs to all kinds of geoinformatic elements, including bus stops. So at least in Finland, there are now these IDs. The problem is that the bus stops won't have the IDs, so then we have to think about whether that is still appropriate to include in OpenStreetMap if it's available as open data, basically the mappings of the coordinates of the stops and then the national identifier.
That's in fact also, Emily, did you also see the similar identification issues in the GIS world and where you have to link one identifier to a certain, or the opposite, if a real-world object to a certain identifier? How do you handle that in GIS in general? Because it's just one station identifier. You can also have a tree identifier and other thing identifiers. How do you handle that in GIS systems?
It's a real problem. I've made up a lot of route names or bus stop names or things like that. One thing I like about OSM is it's easier to leave fields blank rather than making up fake numbers and things and kind of imposing my system of order on somebody else. So that's one thing that's great about OSM. I think one of the core problems that's out there is that informal transit is much more demand responsive than what I would call formal transit. And so in some ways it operates a lot more like what we call paratransit in the United States, which is something where often persons with disabilities can kind of make a call and there's smaller transit buses that will go and kind of take them between points. And so we have much more in common with that community because they're thinking about the same issues of, you know, a stop is a nebulous area, or it may be a point, it may be an area, it may be all things at different times. So it is a real problem.
Okay, so we can take questions from the audience, maybe. Yes. This is a very professional microphone system for passing around.
So I can't use my loud voice?
Well, it's better like this.
Oh, thank you. Okay, so thank you for the great talks, everybody. Now, I come from Cairo, and there we do a project that's called Transport for Cairo. It's actually inspired by Work's digital matatos, so we basically do the exact same thing. And here I wanted to share some of the problems we face, because we also share like the exact same methodology. We get the data and GIS, handle it from there, get the GTFS out there, try to apply OpenTripPlanner on top of it, and route on it. Now, one of the main design decisions that we took is to keep all of our transit information in GTFS separate from OSM. Why? Because we still have to determine what is formal enough or what is scheduled enough to be able to be put in OSM, because that's a rigid structure. Whereas when we keep it in our own with our own schema, GTFS, we can differentiate between both. And I think that's important, because if we just uploaded everything to OSM, we would sort of pollute the OSM master database with data where we're not really sure yet in a peer-reviewed way if it should be there or not. That's the thing. A technical problem we have in routing, and here I'm actually look into the routing engine that you mentioned, Johan. The OSM base map data does not have a lot of sidewalks in Cairo because they do not exist, but people walk on the streets. But that's a problem in routing, because whenever you use a routing engine, you have to walk a kilometer to the station. And even like, if the station is here and the bus stop's there, if I make the bus stops there, it stops a kilometer further away, and you have to walk it all back. So again, I'm faced with an option. Either we need a modified routing engine, or we need to change the data in OSM. But then again, can we add sidewalks where they don't exist in reality? How do we handle that? That's a limitation that we face. And here you mentioned something very interesting. The difference between a PT routing engine and a driving routing engine is schedules. I would love to have a routing engine without schedules. That would work miracles in Cairo. That would work better than what we do now, which is creating estimated schedules. That would be a great option. One final comment. For the unique identifier in GIS, we had the same issue, and we started using what's 3 words as a unique identifier. That creates a unique identifier for every stop, and it works brilliantly. Try it.
A quick comment on what 3 words. A bus stop changes location. That's the difficult part.
And so does UID, because we have clever code that updates it based on the coordinates.
Okay, might be interesting. Yeah.
It's like continuously updating.
Yeah. Is there someone from the panel who wants to elaborate on this comment? Is there someone from the audience who wants to? Or wait, yeah, you.
I want to talk about localization of routing engines. OSRM inherits the fact that its maintainers are sitting in Europe and the US, definitely. Basically, when we think about, it's even worse, when we think about car routing at the moment, we think about the United States. We think about right-hand driving, and localizing routing is a huge issue that, I mean, first, like the inheritance of having your cultural bias not matching to other cultures, totally a big problem. But also the fact that there's different ways of like how routing works in all the world. So left-hand driving versus right-hand driving is a great example. Street name-based instructions versus landmark-based instructions, great example. We don't even have points of interest in OSRM. Like it's not even, we cannot even do this right now. Yeah, I can only say it's a big problem. One of the cool things is that at least in OSRM you can change the profile. If you set up your own instance, you can change the profile to include, to change it the way you want it. So we can do left-hand driving, but you have to set up your own instance for this. We can, you can decide that a highway, a motorway is walkable for pedestrians. We decide that this is not true for the Western world, but that can be changed. So at least there's like some configuration already possible there. To the question of like making public transit routes routable without a schedule in OSRM, yeah, we could probably change the relations to ways and then it just works. We never did this. This sounds like a perfect hack day project to try out.
Let's set up a doodle and let's make it work. Huh? Someone else wants to elaborate on this? No? Okay, we had another question.
Yeah,
sorry.
I just wanted to rebound on the 3 words. The funny thing is we had one provider, Busbud, which just is an aggregator of long-distance buses. And because it's something quite new in Europe, especially in France, and I think in Finland too, in Germany also, they kind of start operating buses without infrastructure for buses. So they stop everyone on the street, and they kind of change the bus stop like every week because some neighbor complains that the bus shouldn't stop there. And they use geohashing for that, because it has the interest that it can be you have a hierarchy. So if you truncate it, it's like a broader zone, and the more digits you add, the more precise it is. And this allowed them to kind of mix stop points, stop areas, and something broader, which cannot be done with 3 words. But I think both approaches have some reasons to exist, and it's a very interesting thing to push forward. Maybe it's a solution.
Okay, thank you.
One more quick thing to what 3 words. Data should be free, service should cost money. That's my opinion, personal opinion. Okay.
Okay, I have a comment and then maybe a question. But I start with a clarification. I think one has always to keep in mind what is the question, what is the underlying question. For me, the question, I'm approaching this discussion with the perspective. I work for a national statistical office, so for me the question is understanding aggregate mobility patterns and mobility trends rather than looking at specific routing for an individual. So keeping in mind this perspective, I found very interesting the discussion on open data and how open data can be used in OpenStreetMap and how OpenStreetMap can be used as a platform to integrate open data. And again, I come from a country where municipalities are increasingly making available open data on their municipal portal, or a regional municipality or a regional entity. So there is an incredible wealth of open data that is completely uncoordinated. You know, when I come from a perspective of a national statistical office and I look at this resource, I mean, you have an incredible diversity of, again, coding system, unit of measure, et cetera, et cetera. So I was wondering if, you know, OpenStreetMap and the community of OpenStreetMap has ever considered making a coordinate effort in trying to make a better use of this resource of municipal open data, where they are available. Because I think this would be extremely valuable. I understand that there is a debate. There was a discussion early this morning on editing and imports, and there are a lot of concern, but I think this is an incredible resource that should be considered, and there should be some discussion. And coming from a National Statistical Office perspective, I would be certainly very interested in being part of that discussion, because it would be of great value for us. The final consideration is that is where in places where these data, open data, are not available, maybe there are other resources that can also be integrated. I'm thinking about big data, and for instance, in my agency, we are starting to look at also the potential of mobile phone data and the use of mobile phone data to track mobility of people. And I've seen examples, for instance, from Mexico, on the use of even social media, tweets, to track mobility of individuals. So I was thinking, again, can OpenStreetMap be used as a platform to track and integrate some of this data for some of these purposes? Again, from an aggregate perspective, that would not be, you know, the routing of the individual person, but to generate an understanding of mobility patterns. I mean, if there is a potential, I think there should be a discussion within the OpenStreetMap community on this. Thank you.
So I can address the first part about OSM being used within governments or institutions. So the American Red Cross, we're a very large bureaucracy, and we've managed to use OSM within the organization. Working with other national governments, I find that there's two questions about OSM. The first one is, how can I trust this? If I'm relying on this and I'm putting this out and kind of endorsing it in a way, how do I know that someone's not going to go in and vandalize the data, or what are the assurances there? So that's the first set of concerns that I've seen governments have. And then the second set is ODBL, and wanting to make sure that they understand the license and their obligations with that data. In terms of encouraging use, I'm not part of the OSM Foundation, so I'm not sure what OSM is kind of officially doing with governments. But I know that large institutions are making a concerted effort to support one another. So in Washington, D.C., the Red Cross, the World Bank, and some departments at the U.S. government are all kind of meeting on a monthly basis so that we can figure out how do we advocate for one another? Because it's a lot easier for us as the Red Cross to say, this is okay, here's our answer to concerns, but also the World Bank is using this, but also the US government is using this, but also all of these other organizations. And that's something where we kind of try to band together, and as a group we're a lot stronger. So I'm not sure what comes from OSM Foundation, but at least the large institutions are kind of very willing to kind of put out their use cases and their experiences to try to help governments and municipalities to become more able to use this.
Okay, so I'm really sorry, but I will have to break there, because that person there is pointing to me. He said, you should stop right now. So first of all, I would like to thank everyone for being here. It was a really interesting session. Thank you, Tristram, Johan, Emily, and Tuka for being last-minute panelists, because I've been a bit chaotic in my invitations. But thank you to everyone, and now up for coffee, that's right. Yeah?